the change in the data and overlapping of the languages and so on. So today we have to keep all these three aspects in the mind. So why is NLP hard, right? So we are using computers since 1950s, 1960s. We have kept hearing that computers understand only 1 0 and nothing else. But why? What is the reason? Computer can perform mathematical operations at much higher speeds than us, right? But then why not they can understand the natural text? They can even understand the codes, right? But why not like natural text? The one word answer is the ambiguity, because whenever we speak, we do not care about its structure. All we care about is whatever we are saying, is the other person able to make something out of it or not. So we have so many words in our languages, like the words which we refer to as polysemy words, where the same word has different meanings and so on. So that languages are developed without taking into consideration how the computer will understand it and all. So that is why they are natural, and that is where the ambiguity comes in. And this is the sole reason why NLP is hard. Here is an example to understand it. So the first sentence says, COVID-19 probe should shift to US, says Chinese epidemiologist, right? Now, just assume that the sentence was in completely in the lowercase or after say lowercase or in uppercasing, right? Then how it would look like? How would you distinguish whether that US is us or the US, that means the United States, right? If I read it as us, the meaning of this sentence changes completely. So COVID-19 probe should shift to us. This is how this is some Chinese person is saying. So this doesn't really make sense, right? So for people, us, it is really easy to understand because US is in uppercase letters. So we can simply make it out that it is about country and not about the word US in the English language, right? The word us in the English language. Here is another example. Command center to track best buses, right? Now here it matters where I give a pause. If I read it like command center to track best buses, right? The meaning has got changed completely. So for us it is easy to disambiguate, but for machine this is like out of syllabus, right? And it is our nature that we usually tend to ignore the ambiguity. So here is a sentence: a truly international collection. The book makes available stories no longer easily accessible. Now, is there any problem with this sentence? Can anyone unmute yourself and tell what is the problem here? Hello, am I audible?
Yes, you are audible. Somebody can unmute and say.
Is there an ambiguity in this sentence? You can just say yes or no.
You can have a hand waving. If you feel that ambiguity is there, please raise your hands.
Okay, sorry, I won't be able to see raised hands. It would be better if you just speak.
Okay.
Okay.
No ambiguity in the sentence?
Guys, I'm not trying to deliver a lecture to you. We can have an interactive session. Feel free to speak. Anyone?
Can you show the sentence again, maybe?
Yeah.
Yeah.
Anyone? Okay, great. So let me proceed. Yeah, so there is an ambiguity here. So the word here is available. Okay, so if I read it like a truly international collection, the book makes available stories no longer easily accessible, right? So it means that the available stories are being made difficult to accessible by this book, right? So meaning the meaning is flipped here, right? So this is the ambiguity which we usually tend to ignore. Here is another example. Elderly with young face increased COVID-19 risk. So is it that if you have a young face, then you have increased COVID-19 risk, right? So this is again a kind of ambiguity which we tend to ignore, but machine doesn't, because for it, that is the meaning, or it may end up with that meaning. It doesn't understand it. So NLP is all about disambiguation. Here is another example. Maharashtra reports increased COVID-19 cases. Now, is it the reports that increased COVID-19 cases, or the so Maharashtra state reports that the cases of COVID-19 have been increased, right? So this is where the disambiguation pitches in. So here you can see we have drawn a tree, right? The root is pointing to some particular word in the sentence, and this is something called as parsing in the NLP, which we use to disambiguate it. And this is all we do in NLP at the base level, right? So we try to disambiguate it, and on the top of it, whatever our downstream task is there, we use it. Okay. So here you can see the whole canvas of NLP. These are all the NLP tasks or applications. The ones in the green are the problems which have been explored since a long time and have been almost solved. So there is part of speech tagging, syntactic parsing, that means the tree which I just showed you just now, query expansion, or recognizing named entities from the sentence. That means recognizing the name of institute or name of place from the sentence, and so on. So tasks like these have been solved. A good progress have been made in these tasks. Then we have another layer of tasks which are for which a good progress has been made, but we are not yet there. I mean, we are not perfect there yet. So this involves discourse integration. This means combining different sentences and then trying to find out the collective meaning. Then we have another task, co-reference resolution, where we try to draw links between the words like he, she, and the names or the entities in the sentence, and so on. Then we have something text similarity. If two sentences are given, we have to predict whether they are similar or not, or if they are similar, how much similar they are. So these are some tasks which are for which a good progress has been made, but still there is a long way to go. Then we have another level of tasks which we recently started. So research for this task was started since decades, but a good progress has been made only recently. So it involves text classification, representing text in form of word vectors, and so on. So most of the classification tasks come under this, and then currently the whole NLP field is like focused on the tasks which are shown in the red. So these tasks require the understanding of natural language generation and understanding to solve them completely. So if we take a look at tasks like this, sarcasm detection, machine translation, dialogue agents, text generation, then these are still we are quite far from achieving good results in these fields. But yes, I mean, this is the future. This is where we are leading. Just a note, so these are all the tasks. So CFILT works on all NLP problems which are mentioned here and also not mentioned here. So there are many more problems actually. So this is like a subset of it. Now we will just run through the different problems. We will start from the basic level. So first problem is of morphology analysis. So here it is. So here we have a word unhappiness. The morphology analysis involves this extracting the different components from the word, right? So here un is a prefix to word happy. Happy can be said as a stem or root or morpheme. And then we have affixes and suffixes. So here ness is suffix. So this this is the very basic tasks which is utilized by the tasks which are at the higher level of this task, right? So the knowledge from this are utilized by those tasks to solve them. Then at the sentence or word level, we have this task that is POS tagging. Here we target to identify which word in the sentence is pronoun, which is noun, which is verb, which is adjective, and so on. So these both things help us to disambiguate the sentence. Okay. So if we know some word is a verb, we know what it denotes some action and not something else, and so on. So this is used in the parsing. Then we have another task that is named entity recognition. Again, this is involved in disambiguation. This would help us filter out the words which are not really ambiguous, because like the words like named entities, objects, and so on. Then this is a parse tree. We have seen this example. Now, just that this parse tree is drawn by incorporating the information obtained from named entity, POS tagging, and morph analysis. And this gives us a good result. What happens here is, for each sentence, we create as many parse trees as possible based on the information from NLP task at the lower levels. We have some mechanisms to give scores to these words in the tree based on the how tree is drawn, and then we combine these scores into a final score for this whole sentence. So this is like rating the sentence. So the tree which gets the highest rating is taken as the final sentence, or the meaning is extracted from that tree. So this really caters to problems which arise because of grammar usually, but it fails to do this for semantics. Okay, so here is one example. Black flowers with soothing voice slip furiously. Grammatically, this sentence is very correct, but just read that sentence. It doesn't make any sense. First of all, a flower having a black color, that is not very common. How can a flower have some voice, and that is too soothing? And then how can it sleep furiously, right? Sleep should be peaceful. So this sentence is grammatically correct, but it makes no sense when we